Good day, good day, good day. Welcome to Yebo Tutor live stream help on this sunny Sunday. I hope everyone is doing great as you are preparing for your final maths exam tomorrow. So I received like some many questions from you guys, like asking for TRIG as well as Euclidean geometry. So I'm just gonna do like a 30 minutes video that we can just catch up on that part. Bear in mind that what is important is to understand that tomorrow you are writing for like 150 and trigonometry contribute 40 marks and Euclidean geometry contribute 50 marks, as well as your analytical geometry is 40 marks as well, then 20 marks for statistics. So make sure that at least Euclidean geometry, analytical, statistics, all the topics, you understand them. So I'm just gonna do like the question from 2019 So I'll be explaining the basic concept of in trigonometry, especially the trig graphs, because many people like especially the trig graphs as well as the theorems. I'm just going to prove one or two theorems for Euclidean geometry as well. So feel free to chat with us on the chat box. I'll be checking it out so that at least I'll be able to assist you as well. When you ask me any question from the chat box, I'll be able to respond in time. Okay. So without wasting much in time, let's go down to the business of the day. So as you can see on the screen, this is 2019 question paper. And it was quite great. That was when I was also doing my metric in 2019. This is the paper we actually wrote, so that's quite great. Okay, cool. Now if it's your first time to be on this channel, please don't forget to subscribe. Don't forget to like and comment and share with friends and family. Thank you to those who are returning and watching our content. Thank you so much. It really means a lot. Now, question 5. We're gonna do fast. And please, if you need more basic information, I would really advise you to go to the description of this video. Then also you can see other videos which we've already streamed, especially on trigonometry. I've done quite some few on trigonometry so that you can get like a basic understanding of what's going on. Great. Question number 5. Simplify the following expression to one trigonometric term. Okay, that's great. So just to highlight some few things right now, tomorrow when you are writing on trigonometry, the first thing which you have to do is to have your reduction formulae. So this one is going to assist you in a long way, because if you don't understand your reduction formula, there is no hope for us tomorrow. So please, for now, please make sure that we master the reduction formula. So we know that in first quadrant all the trig ratios are positive. In the second quadrant only sine theta is positive. On the third quadrant only tan is positive. Then on the last quadrant cos is positive. So that's the cream which I'm giving you now. So we know that this is 0 to 180. So here it's 180 degrees plus this is 360 degrees minus this is 360 degrees plus this is 90 degrees minus 90 degrees plus 180 degrees minus. I didn't put 270 for a reason. I want you guys tomorrow, don't even try to use 270. It's gonna confuse you guys in a lot big way. So what I would advise, just use 180, 360 and 90 degrees. And always remember that when we are using 90 degrees, we are going to apply what we call the core ratios. So we have the core ratio of sine as well as cos. So those two, they are so important. The moment you have cos 90 or sine 90 degrees, your mind must always tell you that now we are talking about the core ratio. So please don't forget that. And also, just to give you a small recap there, we must also remember that we have our identities from grade 11, that tan theta is equal to sine theta over cos theta. Then we also have the second one, which is sine square of theta plus cos square of theta is equal to 1. Then this can be branched to 2.1 and we can make sine square of theta the subject of the formula. Then we'll get 1 minus cos squared of theta. Then we can have also 2.2. Then we make cos square of theta the subject. Then now it's 1 minus sine squared of theta. So this is amazing in a sense that these identities, you will be using them tomorrow. So please, whenever you see tan theta, your mind must run to sine theta over cos theta. Whenever you see sine square of theta plus cos square of theta, your mind must run that it's equivalent to 1. Whenever you see sine square of theta alone, you can convert that sine square of theta to be equal to 1 minus cos square of theta. Then if you only see cos square of theta alone, you must always know that it's going to be 1 minus sine square of theta. Those are the basic things which are so important from grade 11 that I still remember, of course. Then what is also important, I want to highlight that in grade 12, we are introduced to what we call the compound angles. There are 4 of them. The one is sine, the next one is for cos. But now let me just write them down. So we have sine of A plus B. Number 2, we have sine of A minus B. Then now we have cos of A plus B. Then we also have the last one, cos A minus B. These are our compound angles. So this will be sine A cos B minus cos A times sine, sorry, it's plus sine B. So it's sine cos sine. Okay, please always know your compound angles. You must be able to use your compound angles in a correct way. Please, 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 please make sure that you do so. Great. Now also for sine A minus B, it's still going to be sine cos sine, and the signs, they follow what we have on the original here. Now moving forward now to cos now is now a different platform or different way. It's cos sine. So if it was positive here, it's going to be negative, and again cos sine. If it was negative here, it's now going to be positive. Okay, this is so important, this is so crucial. Then also we have what we call the double angles. So the double angles, the first one is cos 2 theta, which can be equal to 2 cos square of theta minus 1. It can also be equal to cos square of theta minus sine square of theta. It can also be equal to 1 minus 2 sine square of theta. Then we have the double angle for sine 2 theta, which is equivalent to 2 cos theta times sine of theta, or 2 sine theta times cos theta. Those are the important aspects of trigonometry. If I didn't forget anything, or maybe if I forgot something, I'm definitely going to remember when we are looking at the questions. Okay, then for the graphs, definitely we must do a practical example. Okay, cool. Now let's work something. Simplify the following expression to one trigonometric ratio. That's straightforward. It's 5 marks. Great. So we are given, okay, question 5, 5.1, sine of x divided by cos x times tan x plus sine of 180 degrees plus x times cos of 90 degrees minus x. Let's go guys, let's go. We don't have time. 5 marks, 5 minutes. 5 marks, 5 minutes. That's the drill. That's what we'll be doing this time around. 5 marks, 5 minutes. Don't do any mistake. 5 marks, 5 minutes. That's the idea behind everything, because if you don't spend more than 5 minutes, it's gonna be a real problem. So 5 marks, 5 minutes. Okay, let's go. So we are given sine x over cos x times tan x. This is quite a great question, because now we must simplify to the simplified trig ratio. Okay, now we say that wherever we see tan, we replace it with sine x over cos x, because that's a double angle. Then here we will use the reduction formula. This is also used sorry, and also on this part we must use the reduction formula, and also understand that this is cos at 90, which means it's going to have a co-ratio. Great, let's go. Sine of x divided by cos of x times tan of x. So we can change this alone. This can be let's just do that now. Let's just do that now so that we can save our life. So sine x over cos x times sine of x over cos x. Okay, plus then sine 180 plus. Where is 180 plus? 180 plus is in the third quadrant, and only tan is positive. So since sine is in the third quadrant, it's gonna be negative. So we have our negative sine of x times cos 90 minus x. 90 minus x is in each quadrant? Is in the first quadrant, and cos is positive in the first quadrant. But since it's cos 90, which means now we must look at the co-ratio. So the co-ratio of cos is sine. So we're gonna have times sine of x. Now let's go. This and this will cancel. Then we have equal to sine of x divided by sine of x minus sine squared of x. Then this times this, then that will be 1. So now we have 1 minus sine squared of x, which is equivalent to cos squared of x. Just like that, we are done. How did we realize that this is equal to cos? Because when we were creating our own identities here, we say that cos squared of theta ma is equal to 1 minus sine squared of theta. Then after that, we are all happy. We get our marks. We are done. 5 marks, 5 minutes. Okay, if you have any question, please stop me on the chat, or you can join the WhatsApp group in the description of this video and ask your question on WhatsApp. I will definitely check it out as well so that I can also answer you. Okay, let's go. 5.2. 5.2 without using a calculator again. So don't use your calculator as well. 3.2 without using a calculator, determine the value of sine squared of 35 degrees minus cos squared of 35 degrees, or divided by 4 sine 10 degrees times cos of 10 degrees. Now let's go, guys. This is gonna be interesting. This is going to be interesting. This is going to be interesting. Okay, so what do we know? We can see that here on top there is a link of what we call a double angle. Bear in mind that we have a double angle of cos 2 theta, which is here that we said cos 2 theta is equal to cos squared of theta minus sine squared of theta. So we can see that the value of theta and theta, they are the same, which is 35 and 35. And also at the same time, we can also see that it's cos squared and sine squared. So now let's make a new equation then. Let's make a new equation so that we can solve that in a proper way. So let's go. If we now equal to, now let's say negative of cos squared 35 degrees minus sine square of 35. Okay, let me just redo with this so that someone can say that no, I understand what's going on. So like we are introducing negative so that we can have like cos squared positive. Okay, but at the same time it's still negative, so it's gonna be cos squared of x minus sine squared of 35. We divide by 4. This can be 2 times 2 sine 10 times cos 10 degrees. Above it's already a double angle, which is negative of cos 2 times 35 divided by 2 times sine 2 times 10, because that's also a double angle. So now we end up having negative cos 70 divided by 2 sine 20 degrees. Now we must solve this without using any calculator. How are we going to solve this, guys? So we can solve this in an easier way. We can introduce on this base. We can say that it's still negative cos of 70 degrees divided by 2 sine of 90 degrees minus 70. Okay, that's still 20. Then this can be got negative cos of 70 degrees divided by 2 cos of 70 as well, because sine at 90 degrees is a co-ratio of cos. So now we can divide this and this, then now we are left with negative 1/2. Then we get our 4 marks, just like that. You have your marks. Let me re-explain this question. It's quite challenging. It needs people to open their eyes. Okay, so also what I would advise tomorrow, please have your eyes open. Think fast, because you don't have time. Okay, so we're given sine squared of 35 minus cos squared of 35 degrees divided by 4 sine 10 times cos 10. So we can see that the angles which we are given here, they are all the same. All these angles, they are all the same. So the 35 and 35 is also the same. So my mind was able to realize that, okay, now we were talking about double angles, and we know that in a double angle we have this double angle, which is cos 2 theta is equal to cos square of theta minus sine square of theta. So these values of theta, we can see that they are all the same, and we can also see that cos and sine, they are both squared. So that led me to now to create this. So if we multiply this negative times this, now we end up having negative cos square of 35 degrees, then negative times negative, that's positive sine squared of 35 degrees. So this and this will still be the same. Okay, so we're just trying to make sure that at least we can have a double angle. And on the base, we saw that it's 4, and we know that 2 times 2 is still 4. But now we know that when it's 2 sine 10 times cos 10, this is now a double angle of cos. So since this is now the double angle of cos, which means we can just now end up having uh 2 sine 2 times 10. Then also here we have cos 2 times 35, because these are double angles. Then now we end up having cos 70 and sine 20. But now when we use the reduction formulae, when we say 90 degrees minus 70, you still get that angle 20 degrees. But now we know that according to the reduction formula, and according to the fact that we are dealing with co-ratios at 90 degrees, especially for sine and cos, we're able to learn that sine 90 minus is has a co-ratio of cos. So now we have cos 70, sorry. So this and this will cancel each other. Then now we end up having negative 1 over 2. Let me check if someone is asking any question. Okay, great. No one asked any question, which means we are all still together. Now, let's move forward to the next question of the day. Given cos 26 degrees is equal to m, calculate without using a calculator. Determine 2 sine square of 77 degrees in terms of m. Okay, the first thing which you have to highlight here, the first thing which you must understand, is that in this problem or in this question, we are given cos of 26 degrees to be equal to m. So we know that cos is adjacent over hypotenuse. So I advise that first thing you do is to draw your right angle triangle. So cos 26 degrees is adjacent over 1, because definitely this is over 1. Now 90 degrees minus 26 degrees, that will be 3 6 64. Yes, so this angle inside is going to be 64. Then now we must calculate this missing side. Then we know that hypotenuse is r squared is equal to x squared plus y squared. Our r is 1, our x is m squared plus y squared. Then y will be equal to 1 minus m squared, all under the square root. Okay, so the value of y here is going to be y equal to 1 minus m squared, all under the root. So at least now we have filled the right angle triangle. So now what do we do after that? We must understand that we are required to solve 2 sine squared of 77 degrees in terms of m. Okay, we must do that in terms of m. So there are two ways I can assist, or I can say this, you can solve this as well. So the first thing which is coming to my mind right now is that we can say 2 sine squared of 90 degrees minus 13 degrees. Then we get that yes, we get that 13 degrees there, so that we can get that 77. Then we know that sine is a co-ratio, so this will be equal to 2 cos squared of 13 degrees. Okay, so that will be now 2 cos squared of 13 degrees. All right, then from that part, let me just do this so that at least it will make a little sense. Okay, yeah, this is the correct format to write it. Sorry, I think someone just said that you're not seeing my screen. Sorry for that. But I think now you must be able to see it. Must be able to see it. Yes, yes. So now this is the correct way to write it. 2 sine open brackets 90 degrees minus 13 is equal, because now that's 77. When you subtract it from 90, you get 13 degrees. So now we are here. We have 2 cos squared of 13 degrees. So as a mathematician, you can include some nice things or like some nice stuff. If we say here equal to 2 cos squared of 13 degrees minus 1 plus 1. Negative 1 plus 1 is equal to 0. Why are we doing this? Because we want to introduce the double angle. So after that, you will now realize that this is now a double angle, which is cos 2 of 13 degrees plus 1, which is now cos of 26 degrees plus 1. Then now we end up having cos 26 was m plus 1. Then you have your answer just like that. Let me explain this again. I feel like it's so crucial. So initially, I thought there are many questions. So I started by doing this Cartesian plane. So what does this mean? Which means tomorrow, the moment you are given this, if there are many questions A, B, C, D, please start by drawing your Cartesian plane. Then after you're done with your Cartesian plane, fill up your Cartesian plane. Fill it up, guys. Please, please fill it up. If you are given one angle, for instance, we're given 26 degrees in this instance, also make sure that you calculate the missing angle, because according to Euclidean geometry, the sum of all the interior angles of a right angle or any triangle, they are equal to 180 degrees. So you must calculate the missing side, because it's going to be 90 plus 26 plus this missing side is equal to 180 degrees. Then of course you can just write also a reason that why are you saying that? It's because angles of a triangle, they are equal to 180, or you can just say some angles of a triangle. Of course, you're going to go to Euclidean geometry so that you can understand the few basic reasoning as well. That's what I did. Then I also find the missing side, so that maybe they was going to ask me cos 64 degrees, maybe. Then they said 3 marks. Then cos 64 in this instance, they're going to be 1 minus m squared divided by 1. Okay, why? Because now you already know that 64 was in the missing side, and also the adjacent of the 64 degrees and cos it's y. So please, tomorrow when you are writing your exam, I advise all of you guys, please make it a point that you start by filling your Cartesian plane, so that you can have, or you can go a long way and solve properly. Let's go. Let's just solve this one. Then that's how we ended up solving this. So we're able to say that 90 minus 30 is 77. Then after that, now we end up having 2 cos squared of 13, because sine at 90 is a co-ratio of cos. So now we end up here. Okay. Then after that, now we end up knowing that negative 1 plus 1 is going to give us 0. So that was just someone who was like, okay, that's what I think, this is the right way. So you can follow your guts and solve that in that manner. Still, you're gonna get the correct answer fast, because bear in mind that you don't have time, but you have to solve according to the marks which are given. 4 marks, 4 minutes. 4 marks, 4 minutes. 4 marks, 4 minutes. 4 marks, 4 minutes. Please make sure that you don't spend more time on one question. Now let's move forward, guys. Let's move forward to 5.4. Now we are on 5.4. Consider f of x. This is now a function. Okay. Consider f of x equal to sine of x plus 25 degrees times cos of 15 degrees minus cos of x plus 25 degrees times sine of 15 degrees. Okay, cool. Then now find the general solution of f of x equal to tan 165, which means, in other words, now our f of x here is now equivalent to tan of 165 degrees. Oh, this is gonna be long. This is gonna be long, and it's gonna be funny at the same time. So how are we gonna solve this? This is the easiest question I can say, because now we just have to apply what we know and we are ready to go. So what are they saying here? They are saying that sine of x plus 25 degrees times cos of 15 degrees minus cos of x plus 25 degrees times sine of 15 degrees is equal to tan of 165 degrees. Great. Now let's go. Let's solve this. Let's solve this, guys. Let's solve this. What do we see? Sine, cos, cosine, sine, cos, cosine. What's that? A compound angle. Sine, cos, cosine. So now we know that we have what we call compound angles. So for the fact that we know that they are compound angles, so now when we are reading this, now this is making more sense. Sine, cos, cosine. Then there's a negative sign, so which means we must apply sine of a minus b. Just like that. Come on, let's go. So this is now sine of a, which is x plus 25, minus b, which is 15 degrees. Then we equivalent it to tan of 165 degrees. Just like that. You're already gone. Then now we have sine of x plus 10 degrees equal to tan of 165 degrees. So what can we do now? Did they say without using a calculator? No, they didn't say that. So we can just use our calculator and calculate tan of what's this? Yes, tan of 165. Okay, so that we can be fast. You can use your calculator there. What's gonna take time? So tan of 165. I'm using mine. Please use yours as well. The sine x plus 10 degrees is equal to tan 65. I'm getting negative 0, 2679. That's what I got. That's what I got from my side. That's what I got from my side. So I believe that my answer is right as well. Great. Now, since we're dealing with sine, of course, it's going to be x plus 10 degrees is equal to sine inverse of negative 0, 2679. Then now we end up having our x plus 10 equal to, then again we use our calculator, guys. Then again we must use our calculator to be able to solve for this problem. Okay, sine inverse of that, what will be the answer? What will be the answer, guys? Come on, I'm waiting for your response from the charts. I'm waiting for a response from the chat, guys, or in the WhatsApp group. Just type something so that at least I know that we are together. So that you can know that we are together. Okay. Assumingly we are together or we are not. So we have 195,54 degrees. Okay. Now we know that for the general solution of sine, it's always, let me write it down first, then I'm going to erase it. Let me use black. So the general solution of sine, it's always, for sine, it's always angle equal to, for instance, now let's just say x is equal to sine inverse of theta plus 360 degrees of k, or x will be equal to 180 degrees minus the calculated angle. This is the calculated angle, guys. This is the calculated angle plus 360 degrees of k. Okay, now let's go. In this instance, let's solve our problem. Back to red. Okay, cool. So x plus 10 degrees is equal to 195,44 54, sorry, plus 360 degrees of k, which is the same as x equal to 185,54 degrees plus 360 degrees of k, where k is the element of integers. Or x will be equal to 180 degrees, okay, and x is equal to 180 degrees, or we can just say Now for the other one, since now we know x plus 10 is equal to 344,46 degrees plus 360 degrees of k, where k is the element of integers. Then therefore our x will be equal to this minus 10, so it's gonna be like 334 46 degrees plus 360 degrees of k, where k is the element of integers. Then you're done solving for that problem. Then you get your full marks. 6 marks just for being able to see that, or just being able to realize that part. Now let's move forward, guys, due to time. Let's move forward, guys, due to time. Let's move forward, guys, due to time. Now we are doing 5.4.2. Determine the values of x in the interval x element from 0 to 364, which f of x will have a minimum value. For which f of x will have minimum value. So this is quite easy, guys, because you must just understand that now your f of x is the same as, let me just write it down. So now f of x is now equal to sine of x plus 10 degrees. Of course, that's what we've already calculated, guys. So definitely you get a mark just for being able to say that. So now for minimum value of sine, is this sine x? Yes, of sine x. For minimum value of sine x, so that will be 270 degrees. Then the maximum, or when I say like for the minimum value now, for minimum value of sine x plus 10, it will be 260 degrees. So you still get your mark. So you still remember when you're plotting the f of the sine function, is just something like this. Yeah, something like this, if I'm not mistaken. Yeah, something like this. So the lowest part, it's 270. Okay, because when you're plotting it, it's like 0, 90, then 180, then 270, then it goes to 360. So it's something like this. Yes. So yeah, something like this. This is 270 now. So that's the lowest part. So that's why we started by like, okay, the minimum value of the original function before it has been reflected or being translated to different sides or being translated to different angles, is going to be equal to 270 degrees. Okay, because that's the minimum. Now, for the minimum value of sine x plus 10, we can actually see that it has been reflected, or it has been shifted 10 units to the left. Okay, if it's positive, it has been shifted to the left. If it's negative, it has shifted to the right. So now we can actually see that 270 degrees minus 10 is equal to 260 degrees. So that was the easiest way I could think of right now. Okay, let's do question 5. This is the last question on trig before I do one question on Euclidean geometry, guys. So now we are on question number 6. Question number 6. I hope the lady who asked me, please listen carefully and listen attentively. Listen so much attentively, because this is where I'll try to explain and be a bit slow so that you can understand what's going on. Cool. Now, in the diagram, the graphs of f of x equal to sine x minus 1 and g of x equal to cos 2x are drawn for the interval x element of negative 90 to 360 degrees. Graphs f and g intersects at a, b. Okay, So they both intersect at point A. You can see that on the graph here, that both function of f of x as well as g of x, they intersect at the point A. They also intersect on this point before 90 degrees, but the one which they've highlighted for us is point A. Then they've given us also point B, which is 360 degrees is to -1. So those are the point of intersection is where the both graphs or both functions which we are given, they have the same values or they have the same coordinates. Now you can see that it's starting from -90 to 360 degrees. Okay, now let's enter. Write down the range of f. So the first thing which you must understand that the range of a function is always looked from the y-intercept, from negative to positive. It's like the amplitude of the function. So it's so important to understand that when they ask you about the range, they want you to talk about the y-intercept. Then when they ask you the domain, they want you to talk about the x-intercept. For instance, in this case, they told us already what's the domain. The domain is from -90 to 360 degrees. The graph, both graphs are starting at -90 degrees and both of them, they are ending at 360 degrees. So that will be our domain. So in this instance, they didn't ask the domain, but they asked the range. So if they had asked for the domain, please don't hesitate to already depict that the domain is looked on the x interval. Okay, then the range is looked on the y interval. So this is the point which we have on the y interval, and also we have another one here at the y interval as well. So what will be our range, guys? So what will be our range? What is going to be our range? What's going to be for our range? That's easy, guys, because we can actually see from the graph. So the range, it's 6.1, of course. So the range of f, they ask for the range of f, will be y is the element from -2 to 0. Okay, or someone can say that y must be less or equal to 0, must be less or equal to -2. So these two, they are still the same. So that will be our range. We can actually see that on our graph, that the graph of f is the one which has point B, and we can see that that graph is down there, it's down there. So please be careful, because now the original function of f of x, if it was only f of x is equal to sine of x, it was going to have -1 to something. But now, since now it has been shifted another -1, which means it has been shifted to the right again. So now it has been shifted downwards 1 plus 1. So it's going to be 1 plus 1. Then we have that -2. That's how we are getting the -2, guys, because the original function of sine of x has the range from -1 to +1. So now the graph has been shifted 1 unit downwards. That's why it's -1. It has been shifted 1 unit downwards from the original function. So we're just going to say -1 minus 1. That's why we have this -2. Then you can see that it's not going above 0. So it's from -2 to 0. Okay, it's from -2 to 0. Please be aware of that. Now, let's go for question 6.2. Write down the value of x in the interval x equal element of -90 to 360 degrees, for which graph f is decreasing. Where is graph f? This is graph f. It's decreasing from here, from 90 degrees till around here. You can actually see that as well. But now they say that the values of x, so you can say from 90 to around 270. Okay, but we can never include both 270 and 90 degrees. So we can actually see our graph is decreasing from 90 degrees less than x less than 270. Please don't use less or equal to, because the point at 90 degrees and at 270 is not yet decreasing, but that's the starting point of it to decrease. So maybe around 90.5 or maybe 90 comma something, that's when it starts to really drastically decrease. So please, there's a difference between less or equal to and only less. There's a difference between greater or equal to on and only greater. So please be careful of those little things. Little things are the ones that matters. Then you get your 2 marks. Then the last question, I'm so happy. The last question. P and Q are points on graphs G and F respectively. So P is on G and Q is on the graph of F, such that PQ is parallel to the y-axis. If PQ lies between A and B, if PQ lies between A and B, okay, determine the values of X for which PQ will be maximum. Whew, that's too much. That's quite a lot of information which have been taught there. But now let's analyze together. Let's solve this, guys. We can do this. We can do this together. So now 6.3, let's solve it. The first thing which is important is to understand that P is a point on the graph of G and Q is a point at the graph of F. So they must be like different. Like we are looking at the difference between P and Q because PQ they are parallel to the y-axis. So what is G? So it's like you're saying G of X minus F of X because G of P, point P is on G of X and point Q is on F of X. So it's going to be now cos of 2x minus sine of x minus 1. So this will be cos 2x minus sine x plus 1. We can convert this in terms of sine since we're already dealing with sine. This can be 1 minus 2 sine squared of x. This is a double angle, guys. And a double angle, of course, can be changed in 3 ways. Okay, minus sine x plus 1. Then now we have 1 minus 2 sine squared of x minus sine of x plus 1. Then 1 plus 1 is equal to 2. So now we have negative 2 sine squared of x minus sine of x plus 2. Okay, that's really amazing. So what we can do here, guys, is to apply, when we are looking at x or like just a parabola, if you want to know the axis of symmetry of a parabola, we know that it's x equal to negative b over 2a. So now we are treating this as the parabola function, or you can actually see this is like a parabola because this is the formula for a parabola. It's the standard form of a parabola. So since we want to know the axis of symmetry of this new function, now we can say sine of x is equal to negative b over 2a. This is the position for that x for the original parabola function. But now since we are talking about x, so we can solve it in this way. What is negative b? Negative b is 1, so it's going to be negative 1. Okay, let me just do this. Sine of x is equal to negative of negative 1 divided by 2 times negative 2. Then now we have sine of x is equal to this times this is positive 1, 2 times then it's negative 4. So it can be like this. So sine x is equal to negative 1 over 4. Then after that, now we need the x value. So x will be equal to sine inverse of 1 over 4. Then we get our sine inverse of 1 over 4. We're gonna get two values, so we're gonna get a negative value. Then you add 180, then you end up having 194 degrees, 48 degrees. Sorry, 194,48, or we can say 360 degrees minus that angle which we found there, which was negative. Then our x will be equal to 345,52 degrees. Okay, so that you can have positive angles. So these are the 2 points of x which we were looking for in this question, in this problem. Now let's move on to, okay, this is also TRIG, but this one is easy, guys. Definitely we all know this. I've done this many times. Please do check them because It's only 10 marks. Now I want us to go to this proof in Euclidean geometry. Someone asked me to prove. Where is this proof? Here it is. So I'm just gonna do the proof because other questions we have already done them. So on question number 10, now I want us to do question number 10 because someone asked me to prove this theorem for you guys. This theorem is quite easy and straightforward, and we must all be able to prove. We must all be able to prove this theorem. So I wanna draw it. Let me just draw it. So in the diagram, triangle ABC is drawn. D is a point on AB and E is a point on AC such that DE is parallel to BC and BE and DC are drawn for you. Now, use the diagram to prove the theorem which says that a line drawn parallel to one side of a triangle divides the other two sides proportionally. In other words, prove that AD over DB is equal to AE over EC. That's fantastic. I need 6 marks, guys. Let's draw the triangle. So we are given, this is the triangle. It's something like this. So we have A, B, C, then we have D, E. This is parallel to this one. Then they constructed BE and also DC. Okay, so what I'm gonna do is gonna create 2 heights. Now let me use different pen again. It's black. So I wanna create a new height here. It is 90 degrees there. Then this, I'm gonna call it my H2, height 2. Then I create another one here again, so it's gonna be somewhere like this. This is 90. This will be my H1. Okay, so this is height 1. This another one is height 2. Sorry guys, someone also reminded me that you can't see my screen. Okay, thank you. I think now you can see it. So now let's prove this theorem together so that it can be fun. So now we have the first thing which we did, which has marks, is for you to say that construct what did we do? We draw H1, which is the height, the first height, from E, which is perpendicular to AD. Then we also draw height number 2 from E perpendicular to AD, so that you get your full marks. Guys, in Euclidean geometry, explaining and reasoning is what is important. No one cares about a lot of things in Euclidean geometry. Even if your answer is correct, if you don't say why are you saying that your answer is correct, you won't get any marks. You won't get any marks because it's going to be a problem for you. So please make sure that make it a point. Please make it a point that whatever answer you give a reason. Why are you saying this is the answer? Why are you saying this is the answer? Because if you show that you are having the reasoning mentality, you're going to be given marks for that. So we say that the first thing which we did, so in other words, we are saying what we are doing in order for us to prove this theorem. This is called the prop theorem from grade 12. Okay, so when we are so the first thing we construct height 1 from E perpendicular to AD because of that 90 degrees, because that height which we are constructing, when they attach AD and AE, they are forming a 90 degrees. That makes it a perpendicular line or perpendicular bisector. Now let's go now first, the area of triangle ADE is equal to 1 over 2, which is of course half base times height. So half base AD times H1. Okay, this is the triangle A D E, and we can see that if we look at this side, we can see that that's height. This is the height which we are looking at. Okay. So tomorrow, don't hesitate to turn your paper upside down, as I'm also doing right now, because it's important for you to have correct marks. So in triangle ADE, so this is the triangle here like this, and it has the base AD. Then since it has that base AD, it also has like a perpendicular height, which is height 1. So that's why we say that the area of triangle ADE is equal to 1 over 2 AD times H1. Now let's look at the area of triangle BDE, because like we are dividing these two guys. Okay, so where is BDE? This is B, D, and E. So we can see that this is the triangle BDE, and we can see that this is the perpendicular height. Again, they have the same height, even if BD is BDE, but they still have that perpendicular height, height 1. So this is going to be equal to 1 over 2 BD, or you can say DB. You just say DB, okay, times height 1, because that's what we want. And this is now equal to AD over DB, because this and this will cancel, and 1 over 2 and 1 over 2 will cancel. Now again, let's look at the other side now for height 2. Area of triangle AED divided by area of triangle DEC. So again, it's half base, half AE times height 2 and 1 over 2 times DE. We can say CE, since AC, sorry, since we must have a correct way or correct answer, times H2. Okay, let's go again. This is now the triangle which we are looking at, AED. Then we can see that the height is height 2. We can see that this is the height 2 here for this triangle. This triangle AED. We can see the height which we have here is H2. That makes it so sweet, because now we are seeing all of this. Okay, then after that we have our 1 over 2 AE times H2. Then for DEC, it's gonna be DEC. Okay, this is DEC, D, E, and C. We can actually see that now we are looking at this side. We can see that it has the height there, which is this one. So it also have the same height, height 2. Then we go there, then we divide. So this is going to be equal to AE over EC. This is what they actually ask us to prove, guys. They say that prove that AD over DB is equal to AE over AEC. We've already proved it, but now how are we going to connect these two ratios? How are we going to do that? We're going to do that in the simplest way, because now we must now understand that but the area of triangle BDE is equal to the area of triangle DEC. Okay, DEC. So the area of triangle BDE is equal to the area of triangle DEC. Why? Because they have the same base, which means same height. Okay, or we can just say that because DE is parallel to BC. Then now, since we say that these two base triangles were equal, then we can say that AD over DB is equal to AE over EC. So what is important? It's like you're telling a story in Euclidean geometry, but it's not a story per se. but it's you explaining what's really going on, what's going on, what's going on, what's going on. So you are explaining. So I wanted to just prove this guys, the first one only, because I wanted you all guys to see what's really going on here. Because what is important is to understand the few things that when you are proving in Euclidean geometry, you must be able to use the knowledge which you have been taught in other sections. For instance, understanding this is a triangle, and a triangle, in order for you to calculate the area of a triangle, it's half base times height. If you want to calculate this, it's this times this. If you must know the interior angles of a triangle, they all add up to 360. So all of those things, they are so important, they are so crucial and so important. Okay, now um let me just, I want to show you something fast of these theorems. Show you something fast of this theorem. Just give me a sec. Show you something, guys. If you have a question, please feel free to type on the comment section uh, before we sign out. Mm. Feel free to comment and ask us anything which you want to ask us. Where is this? Okay, it is. I want to explain this part for the Euclidean geometry and theories. Explain this part of Euclidean geometry and theories. Mm. Here we go. So when we went to Mtata this year with the Yebo Tutor team, we created like a workbook for them. I hope you can see my workbook. So here is what we created for them. So when I was doing this, I created this, and I was like, okay, let me start by having these few things which are important. So these are the acceptable reasons for Euclidean geometry. You cannot just answer using any reasoning, but you must use this reasoning of Euclidean geometry. Please make it a point. So the first one, I had angles on a straight line, parallel lines, knowing that they are alternating angles, they are corresponding angles, they are co-interior angles, knowing these few things. And also now in triangles, I even highlighted the part of triangle. I'm gonna give you this pamphlet also in the WhatsApp group as well. So if you're not on the WhatsApp group, join the WhatsApp group from the description of the video so that you can be able to receive this pamphlet. Then this is the theorems. So I made sure that everything is there. So this was there. Great, here we are. These are the theorems which we have: theorem 1 converse, and this one is the most important, which is likely to be asked tomorrow, to prove that the angle at the center is equal to twice at the circumference. This is so important. Or they might ask you to prove theorem number 7, which is the turn chord theorem. Where is it? Here it is. Yes, this is the turn chord theorem. They must ask you to do the turn chord theorem. So please, guys, be careful of the turn chord. If you want more explanation, guys, just tell me on the WhatsApp group so that I can also hook you up and assist you. But at the point or at the moment, please be careful, guys. Please be careful. Then this is also the proportionality theorem. Then also we also have the special case here. Okay, so these things are so important, they are so crucial. Then this one also, it's important, the similarity theorem. The similarity theorem is usually used to answer question number 11 or question number 10, in the sense that now you are answering in this direction, that now you are looking at two triangles. You must see they will give you one big triangle and a small triangle inside the big triangle. Please be able to see that, okay, this one, what is the relationship between the small one and the big one. That's when now your reason will be angle, angle, angle. So this is so important, and also this is also important. So as I was saying, that we have parallel lines, you must know that this angle is equal to this angle. Why? They are corresponding angles. This angle plus this angle, they are 180 degrees, provided that these two lines are parallel. Okay, if these two lines are parallel, which means these two, they are co-interior angles, because when you add the two angles, you must get 180 degrees. Then this angle B and this angle is also equal to each other, because they are alternating angles. If you are stating the parallel lines, or saying that these are alternating angles, or these are parallel lines, please always make it a point that you state the parallel lines which you are saying or which you are implying. Then we know that this plus this is equal to 180 degrees. They are angles on a straight line. Then we know that when we cross like this angle and then this angle, they are equivalent to each other, vertically opposite angles. This and this, they are also equal to each other, vertically opposite angles. Then these now were the questions. So guys, this is what I had prepared for you first. I wish you all the best with your test tomorrow. I wish that you go there, you go and pass and make us proud. Have a great evening. Continue practicing. If you have any question, just ask on the WhatsApp, or you can comment on the comment section. I'll check it out so that I can assist you guys. It was nice to have you guys. I hope you all enjoy the videos, which are this live recording which we did together. I hope you really enjoy. Have a great day and have a great evening. Cheers.